Hi guys, this video is designed for if you want to study for a test, and then also if you were absent for any day when we were learning about designing experiments and variables in class. This is a way you can make that up. So you would just need to watch this video and then do the variables makeup assignment, and then you can make up any day you missed in class where we were learning about how to design experiments and variables and stuff like that. So this video could be used for studying or for makeup, either way. So let's go ahead and talk about how to design experiments. And here's our research question. Is it harder to swim in a pool full of syrup than it is in a pool full of water? And we're going to design an experiment that we could use to test this question. So our first step is going to be to write a hypothesis, and with a hypothesis we always use these three words: if, then, and because. If we use those three words, we usually will have a better hypothesis. So let's write one based on what we think. So for example, if I think that I will swim more slowly in a pool of syrup than I would in a pool of water, then that would be what I would write in my hypothesis. So I'm going to write one like that. But if you think something different, then you could write your hypothesis about whatever you think. So I'm going to start out with if. It could be something like, if I swim in a pool of syrup, then, and then I'm going to say what I think would happen. Then I will be slower. Whoops. Having stylus issues. Then I will be slower. So I've used if, and I've used then so far. Last I need to say why. So I'm going to use because. And then you put why you think that. So maybe I think that because syrup is thicker than water. So I'm going to say because syrup is thicker. This would be a good hypothesis because it has if, then, and because. It says what I think will happen and why I think that will happen. If I swim in a pool of syrup, then I will be slower because syrup is thicker. It'd be good to say thicker than water. Okay, now we're going to design an experiment that will help us test this. So first, let's talk about the independent variable. The way I help my students remember independent variable is it's the thing that I change, because independent variable starts with an I. So the thing the scientist changes. In this case, let's say for our experiment we're going to have two pools, one full of syrup and one full of water, and we're going to have someone swim in both pools, and then we'll see which pool he or she can swim faster in or slower in, right? We'll time how long it takes for them to swim across the pool and see if there's a difference in the time, right? So in this case, we're changing the liquid in the pool. We're changing whether the pool is full of syrup or full of water. So that would be our independent variable in this case. We also need a dependent variable, and that's the thing you measure. So in the case of our experiment where we have two pools, one full of syrup and one full of water, we're going to have a swimmer go in each pool. We're going to measure how long it takes for them to swim the full length of the pool. So in this case, the thing we measure is going to be the time it takes to swim across the pool, okay? So that would be the dependent variable in this case. The control group is going to be the original unchanged group. So for example, in this case with the pool of syrup and the pool of water, the original group would be the pool of water because usually we fill pools with water. Usually when we're swimming, it's going to be in water, right? And that's what we're going to compare our experimental group to. Our experimental group is the thing that we're trying to find out. So we're trying to find out about what it would be like to swim in a pool of syrup. So that is our experimental group, the pool of syrup, because that's the thing we don't know about. And that's the reason we're doing the experiment, is to find out how fast you can swim in a pool of syrup. After we have tested that, we're going to compare it to the pool of water, right? Pool of water is our control group because we already know how fast we can swim in a pool of water. That's something we've already done. It's original, unchanged, it's what we usually do. So the pool of water is the control group in this case. And then one of the most important, oh yeah, there's a picture of the control group, the pool of water. One of the most important things is the constants. These are the things you keep the same, and they are so important because if you change too many things at once in an experiment, you totally mess up your results. In fact, you can only change one thing at a time. And that one thing you change is the independent variable. So in our swimming experiment, we're only going to change whether the pool has syrup in it or water in it. That's our independent variable. But there are some things we're not going to change. For example, we are not going to change the swimmer. And let me explain to you why. Let's imagine that we have Miss Randall, that's me, swimming in the pool of syrup, and Michael Phelps swimming in the pool of water. Now, me and Michael Phelps do not have the same swimming times. I'm a much slower swimmer than him, right? So we wouldn't get accurate results about whether it's faster to swim in syrup or water because we have two swimmers with different swimming speeds. So the way to make it accurate and good results would be to have Michael Phelps swim in both pools or to have me swim in both pools. We need to have the same swimmer. The swimmer needs to be constant. Otherwise, it'll totally mess up your results.
Julie Will Leitner, will you please come to the main office? Julie Will Leitner to the main office. Thank you.
I don't know if you could hear that. That was a little announcement. Anyways, there are other things we need to keep constant as well, like the size of the pool. Now, it also wouldn't give us good results if we had Michael Phelps swim in a tiny pool of syrup and a huge pool of water, right? The pools need to be the same size, otherwise we don't know how the liquid affects it. So swimmer needs to be constant, size needs to be constant, probably the temperature needs to be constant, right? Temperature can affect like how thick the syrup is, right? So those are some examples of things we would want to keep constant in our experiment. And of course you could think of some other ones as well, but the main thing is there's only one thing you can change in an experiment at a time. If you change more than one thing at a time, then you will mess up your results. Okay, so they actually did this experiment. Actually, several researchers, several groups have done this. And they found that humans can swim just as fast in a pool of syrup as in a pool of water, usually. But if they have really thick syrup, like thick like glue, like that thick, then it won't work. Like humans are too slow in that if it's like glue, right? But if it's like regular syrup that's not super, super sticky like glue, then they can swim just as fast as in water. And here's why. It's because when the swimmer is pushing on the syrup is thicker, so it actually pushes them forward more than water would. So that's kind of interesting. They found that syrup you can swim in just as well as water for the most part. Okay, I'm going to have you go ahead and do a practice now. So for this practice, it says you are making a commercial for Bounty paper towels where you demonstrate how effective they are compared to other paper towels, like an off-brand or a Walmart brand. Design an experiment including the hypothesis, independent variable, dependent variable, control group, and constants. So the best way for you to learn and like prepare for the test would be for you to pause this video, do this on your own, like on a piece of paper, and then unpause the video and see if you were right. Because if you just watch me do it, you can be like, oh yeah, that makes sense. But if you do it yourself first, then you'll know for sure if you can do it yourself on the test. So I would recommend pausing now and then do the practice on your own and then unpause and I'll tell you the answers and you can see if you're right. So go ahead and pause it now. And hopefully you paused it and got your own answers. So now let's go ahead and talk about it. So we want to see if Bounty paper towels are effective or more or less effective than like the off-brand. So the first thing we need to do is write a hypothesis. We need those three words, if, then, and because in our hypothesis. So, and remember, we're just going to say what we think. And since I'm making a commercial for Bounty paper towels, I think that they are going to be better than the off-brand. So I'm going to say, if I use Bounty paper towels, then I will need less, like to clean up a mess or something. So I've used my if, I've used then, I just need because. So because they are thicker. Let's say that Bounty paper towels are like thicker. and I've used my because. So if I use Bounty paper towels, then I will need less because they are thicker. And I'm sorry my handwriting is messy. It's hard to write on the computer screen. So that would be a good hypothesis. Now, if you don't think that, then you just put whatever you think. You could have said something different. Like you could have said, if I use Bounty paper towels, then I will need more because they are thinner. Maybe that's what you think. So just put whatever you think, but make sure you have reasoning with this because. Now I'm gonna erase this so that I can start writing the other things. Okay, so let's talk about our independent variable. Our independent variable is the thing that I change. As the scientist, the one thing I'm gonna change. In this case, I'm gonna clean up a mess with Bounty paper towels, and I'm gonna clean up the same mess again with the off-brand. So the only thing I'm changing is the brand of the paper towels, right? I'm just gonna do an arrow so you know that's the independent variable. Independent variable would be the brand. Now let's go ahead and talk about the dependent variable. The dependent variable is the thing you measure. So in this case, we're going to measure how many paper towels we need to clean up the mess, right? So let's say we've got like some spilled SpaghettiOs, 2 identical piles of spilled SpaghettiOs. We're going to see how many Bounty paper towels it takes to clean that up. Then we're going to try it with the off-brand and see how many of those it takes to clean it up. And we're measuring how many does it take, right? So our dependent variable is going to be how many paper towels it takes to clean up the mess, okay? How many paper towels? And then the control group, remember that's the original unchanged group that's like normal, right? So in this case, actually it's gonna be the off-brand paper towels that is the control group because we already know how those work. We're trying to find out about Bounty, right? We're gonna compare Bounty to what we usually use, which is the off-brand, okay? And then constants, super important. Remember, we can only change one thing at a time in an experiment, and if we change more than that, it'll totally mess up our results, right? So imagine this. What if we had some spilled milk and some spilled SpaghettiOs? We cleaned up the SpaghettiOs with Bounty, and then we cleaned up the milk with the off-brand paper towels. That wouldn't really tell us anything about the effectiveness because we just cleaned up 2 different messes with 2 different paper towels. So we're not going to know which one's better. We need to use 2 different paper towels to clean up the same mess, 2 identical messes. So like maybe 2 piles of SpaghettiOs, right? Then we'll be able to know which one is more effective. So one constant would be the type of mess, whether it's spilled milk or SpaghettiOs or whatever. Another thing would probably be the size of the mess. You don't want to clean up a huge pile of SpaghettiOs with one brand and then a small pile with the other, right? So those are examples of things that you need to keep constant, otherwise it'll totally mess up your results. And of course you could think of more. But hopefully that was good practice for you. If you would like more practice, that's what the variables makeup assignment is for. If you were absent on a day when we learned this, then you use the makeup assignment to make up your work for that day. So instead of the in-class work, you do the makeup assignment on Canvas. If you were in class for that day, but you just want to like prepare for the test, then you don't have to do the makeup assignment, but it might be a good way for you to get ready for the test. It would be some good practice. So that's there for you as well. I hope that was helpful and good luck.